Alright, today I'll talk about the problem musical themes. So in this problem, we're basically required to find the longest length for two similar and non-overlapping segments. And so this part we can use normal dynamic programming to solve this, but the first part is you need to compute the difference between each of these numbers. Then since you compute the difference, then you'll be able to find the ones that are similar to each other. So for example, right now these few parts might all look different, but then if you compute the distance or the difference between each of these adjacent few elements, then you will be able to have a few same elements in this array. And here we use dynamic programming. This dp vector will store the dp for the previous level, and this temporary vector will be the current data for a different level. And what I mean by levels is basically we'll use a nested loop. This first I will keep track of the ending of this first section. So because we need to find because it will appear somewhere else in this piece of music, and that means it will at least appear 2 times. So we just have to find the ones that appear 2 times. So this will be the end of the first subsequence, and J will represent the end of the second subsequence. And here, after reading the input, I will first create this difference array. I just get the difference of this current element minus the previous element, and set the difference for the first one to 99, just so we don't get any messed up subsequences in this calculation. So here we will just loop through these and check if these two current differences are the same. If they are the same, that means they can have an extra subsequence. This can be a subsequence, or this can be added to a previous subsequence, which means, for example, if before this j and this I, we already have a subsequence, then we can add these two into the subsequence. So here we also have to make sure that so this dp will store the previous subsequence length. And we have to make sure that this previous subsequence length is smaller than j minus I. Because if it's greater than or equal to j minus I, we're going to have overlapped elements if we include these two differences into this dp as well. So we have to make sure that they're smaller than the difference between j and I, so we don't overlap. And to get it, we will just set this temporary array to the dp j minus 1 plus 1. And we plus 1 because now we just increase this length of this subsequence. So here we will check if there's an empty element in front of these two subsequences. And we check the empty element because the beginning can be different for these two differences, because the differences are only calculated for this current element minus the element before it. And for example here, we have this 1. This 1 could be included in some subsequence, but maybe in that subsequence, since this difference is 99, it will always not be counted as here. So to count this 1 as well, we can use an if to check if there's still enough length for us to choose another element. And here, these two will just check if the current length is smaller than the distance between j to I. So j to I is basically the maximum length that we can get. And if this is still smaller than the maximum length that we can get for this current j, and also if this temporary j or this distance that we just got is still smaller than I, this means that we can still have more elements all the way up to I elements for this subsequence. Then if this is the case, then we can choose whatever is in front of these two. So we can choose whatever is in front of this second subsequence and this first subsequence, because the difference is the same. So we know that those two can also be included. So here we'll just get we will plus 1 to this length, and we will get the maximum that we currently have. So here we'll just compare it with a length from outside, and if this is longer than the length of the maximum subsequence, we'll just change it to this. And every time we'll just set this new DP to this temporary vector, because you cannot use a 2D array because it will be too big for the compiler. And every time you loop through each of these new DP, you have to remember to set this temporary vector arrow to 0 again, because some of them might not be set to some other DP values. Then you're going to have some overlaps and errors in the DP array. And finally, after you got the maximum length of the subsequence, just check if it's smaller than 5. If it's smaller than 5, then we know that it's not a seam, because a seam has to be at least 5 nodes long. So here, if it's less than 5, then we'll just print out 0, meaning that there's no seam. And otherwise, we'll just print out the m, meaning the length of the longest seam that we have.